Imagine coding without a safety net. Bugs crashing your app just like uninvited guests. TypeScript is your safety net for JavaScript. It's a superset that adds static typing to catch errors just before they hit, making your code rock solid. Plus, it supercharges your editor with some smart tools like code suggestions that feel like magic. And today we're going to unlock the power of TypeScript type safety together. So, what is exactly TypeScript? Imagine a building or a house without any blueprint. It's going to be a chaos, right? So, TypeScript is like a blueprint for JavaScript. It's a superset, which means it includes all JavaScript features plus static typing. This catches errors while you code, not when users see broken app. So, why should you choose TypeScript? Let's break it down. Imagine that you are a detective trying to solve a mystery. Without clues, you're lost. TypeScript static typing is like those clues. It spots errors very early, before your code hits the browser, making the project super reliable and easy to maintain. Next, think of your code editor as a super smart assistant. TypeScript powers it with features like smart navigation and auto-completion, so you code faster with fewer mistakes. And for big apps, its object-oriented tools like classes help you build scalable code that doesn't crumble under any pressure. And TypeScript benefits don't stop there. Let's keep going. Why use TypeScript? TypeScript isn't just about safety, it's about staying modern. It lets you use the latest JavaScript features like arrow functions or async await and compiles them to work on any browser. And the best part? You don't have to rewrite all JavaScript code, which makes it a game changer for teams upgrading projects bit by bit. JavaScript dynamic typing is like painting freehand. It's fun but messy. TypeScript adds structure with types like enumerations, tuples, and unions, and some others, which we're going to check out very soon. These let you define exactly what your data should be, cutting potential bugs. And let's start with some primitive types. You've got Boolean for true and false, number for any number, string for text, big integer for huge numbers, and symbol for unique IDs, and undefined or null for empty values. These let you say this variable is a string, for example, and nothing else. It's the foundation for TypeScript safety net. And now let's talk about some special types. So here we can see any type, which is a very risky one. Then void for functions that return nothing, never for code that never finishes, and unknown, which is a little bit safer option than any. And first, let's talk about the tempting but very tricky any type. So any lets you assign anything to a variable, just like in JavaScript. In this example, we flip from a string to a number and call a string method. No complaints at compile time, but if value isn't a string at runtime, wow, crash. It's like eating junk food. So using any is very tempting but not healthy for your code base. Do you want a safer option? Let's meet unknown. Unknown is just like a locked box. You can store anything, but you have to check what's inside before using it. Here we assign a string to value, but TypeScript makes us verify it's a string before call to uppercase. This keeps your code safe from surprises, like a security guard for your variables. So, never type is for code that never returns, like a function that always throws an error. In this example, our error function tosses an error and stops. Never helps TypeScript catch logical mistakes. And now let's take a look at void. Void is like a nothing to see here sign. It's used for functions that do their job but don't return anything. In this example, log message prints message but gives back nothing. So it's void. It's a simple way to tell TypeScript this function is done. Now we are going to compare interfaces and typologies. Interfaces and typologies both define data shapes. Interfaces are great for objects and can be extended or merged, while typologies are more flexible, handling union, tuples, and even primitives. Understanding the differences help you pick the right tool for your code's needs. So, interfaces can be extended. Interfaces are like building blocks you can stack. Using extends, you can create a new interface that inherits from another. In this example, employee builds on person, adding a job title to name and age. This makes it easy to create structured, reusable data shapes like blueprints for complex objects in big projects. And interfaces have another cool trick, which is declaration merging. So interfaces support declaration merging. So they can be reopened and expanded. Here we define person with a name, then add middle name later. TypeScript merges them, so person now has both. This is handy for extending libraries or gradually building complex types without rewriting code. Typologies can represent primitives, unions, tuples, and many more. Type can define almost anything. They handle unions like string or number, tuples for coordinates, or even primitives. This flexibility makes them perfect for unique or complex data shapes that interfaces can't easily cover, giving you more ways to model your data. Composite types include arrays for lists of the same type, tuples for fixed sets of mixed types, and union and intersection types for flexible or combined data. These help you organize data precisely, whether it's a list of scores or a name-age pair. Let's break them down. And first, we are going to unpack arrays. Arrays are like a playlist. All tracks must be the same type. In this example, numbers holds only numbers. Add another number, it's going to be fine. A string, TypeScript says run genre. This keeps list consistent, which is crucial for things like user IDs or prices in your app. Tuples, on the other hand, are more like a boxed set. Each element in tuples has a specific type. Here person is a string and number in that order. Swap them, TypeScript blocks it. Tuples are perfect for fixed data, like coordinates or a name-age combo, keeping everything in its place. And now let's explore union types. Union types let a variable be one of several types, like a string or a number. In this code, value can be a string or a number. Both work fine. But if you try a boolean, TypeScript says not on the list. So this is great for handling flexible data like API responses while keeping things safe. So now let's talk about intersection types. If union types offer choices, intersection types combine. Let's see how. Intersection types combine multiple types into one. So here, person employee needs a name from person and a job title from employee. This ensures objects meet multiple requirements, which is perfect for complex systems. Now let's talk Now let's talk about enumeration types. In this example, color offers red, green, and blue, each tied to a number. Set favorite color to green and you get 1. Enumeration swap vague numbers for clear names, making code easier to read, like choosing green for a button color. Literal types lock a variable to a specific value. You can use string literals like success or error, numeric literals like 1 to 6 for a dice roll, or Boolean literals like true. So in this specific example, status can only be success or error. Combining them with unions gives you precise control, which is perfect for things like API states. Generics let you write flexible code that works with any type, specified when used. In this example, the identity function returns whatever type you pass in, whether it's a string, number, or anything. You can also add constraints to limit types, like requiring a length property. Generics make your code reusable and type safe, which is ideal for libraries or shared functions. Now we're going to talk about advanced types. Type assertions let you tell TypeScript, trust me, this is a string, when you know better than a compiler. Non-null assertions say, this can be null, like in this example with getElementById. These tools are handy, but use them very carefully and double-check to avoid mistakes. Utility types help you tweak existing types without starting from scratch. And first, let's check out partial and read-only. Partial makes all properties optional. So here, partial user only needs a name instead of both ID and name. Read-only locks properties, so read-only user can be changed after creation. These are great for flexible or protected data like optional form inputs or immutable configs. Pick lets you grab specific properties, just like ID and name from a user type, which is perfect for slimmed down data. Omit does the opposite, dropping properties like email to focus on what's left. These are awesome for tailoring types, like creating a user preview without sensitive information. Well, it's time to wrap things up. TypeScript is your coding superpower. It catches errors early with type safety, which makes code easier to read with clear types, and it boosts tools with features like autocompletion. It scales big apps, supports modern JavaScript, and compiles to work everywhere. Sure, there is a learning curve, but the payoff, like fewer bugs, faster coding, and happier teams, is huge. Try, try TypeScript on your next project and unlock type safety. Thanks for watching.